Well, hi everyone and welcome again. Just want to thank Adam for the quick introduction, and we're just going to share our presentation here to get it going. If you just bear with me half a second. Sorry. Click. Okay. Perfect. All right. Okay. All right. I think we've got our screen shared. Coming up. Try again. Yep. All right. There we go. Now we're in. Thanks for your patience. And welcome again. And thanks to our IT department who have been carrying us through all our connection today. They're doing a great job. Adam had mentioned in his introduction about customer support contacts. I'm just displaying a slide here right now. Highlights of that are going to be, of course, you met Amanda as customer support manager, Adam as a supervisor of customer support. We also cover over technical publications, online services with Karen Stewart, and listed as well are customer support representatives as they are now, with Mandy handling the US and international, and Karen Fitzpatrick and Sahid Olotu in Eastern Canada, and Julia Castro Rodriguez and Aaron Young for your Western Canada, and we're looking for one more. So these are your people to reach out to at any time you need assistance. And we're going to flip over to the technical support side more. That's where we come in. So I'm going to talk about our technical support team quickly, the Canadian fleet in operation right now, and then we're going to go through the technical in-service subjects, top company objectives, things like that, and clean it up or finish it off with some product improvements. So our support team, you met Michelle at the very beginning for the introduction, and we thank him for that. So Michelle's our Director of Support and Services now for a couple of years. Under there, we've got Blair, who's our Supervisor of all tech support, and Brad Morgan as our avionics expert for all of Canada, and of course, other places when it comes to our STCs. And then we have a team of 5 regional technical representatives, Peter Swinard on the West Coast, Jared Creeley sort of in the interior of BC. So we break out BC and Yukon as one region. Central Canada for Thorsten. He's handling Alberta, Saskatchewan, Manitoba, and up into the territories. I pick up where he leaves off. So with Ontario, and then Andre Gay for Eastern Canada. So I just ask you to remember there's 5 of us. If you need to reach us, you can reach us at that number at the bottom on after hours AOG. Just remember we have 5 guys, mainly specific to 5 or to the regions, to 5 regions. I asked you to remember that because this is our fleet currently running in Canada right now. We have 730 aircraft in Canada. Operational. And what you'll see there is I'm not going to go through all the big numbers. I just want to point out that in many of these models, we have many variants. For the H125 and 350, we have 5 or 6 variants. 130 has a couple, the 145, 2 or 3, 355 the same, 135 has variants, 365, and our Super Pumas as well. We're looking at 3 variants in Canada right now. So we have a lot of variants and a lot in just a few types. And so this is where you get to remember that, because you have 5 tech reps handling all these 730 aircraft, but with multiple variants. When you contact us, we want to be as efficient as we can. We want to keep you going. We want to keep you flying. We want to keep your maintenance going. So there's some essential stuff that we need to know, because we may not have our finger on the pulse of your entire fleet. So we're going to need to know your helicopter type, model, and serial number. Very important. We often ask for total airframe time. This is a number that goes into our internal database, which is used for total flight hours per year, fleet totals, and just used in general against fleet safety. We need a clear description of what's going on. If it's structural or anything like that, we need to know about any previous repairs, any troubleshooting you've done. That means giving us references to the AMM or any CMM documents, maybe wiring diagram manuals, anything you can give us to get us to where you are the fastest is the best. Photos are great. They really are worth 1,000 words a lot of times. And then when we jump in and start to help, we're going to look for systematic follow through on everything. Okay. So, because really, we just want you flying and safely at the same time. So let's talk about flying and being safe in service. So of course, as we operate, we have things happen to the aircraft over time. So what we are always looking for is a return of experience. And you'll see that in different things where we call it retex. So that comes from return of experience. That means, what are you reporting to us? When we get information on failures or things like that, we will raise an in-service incident report if it's necessary. This is kind of like the service difficulty report that Transport Canada requires, but it's internal. So you would do an SDR, but you would let us know, and we will raise an in-service incident report internally. These are gathered up, and they help us to identify and prioritize what we would call irritants in operation. And those become what we call top company objectives, things to get done this year, over the next few years, to improve our product. We take time to determine root cause, and then we define protective and corrective measures. So a protective action would be something like a reminder of, correct maintenance or operational procedures, or as well measures to maintain the safety of your flight, which could mean additional maintenance. Maybe we're adding inspections or replacing certain things, or we might be increasing the frequency of your inspection. You might get a new limitation on your flight envelope or operating timer cycles on a component. That through this process, though, we also come up with a corrective action, which would include modifications and improvements that get rid of the risk of the failure. And once we have that, then we can return back to the simplified maintenance. So we keep you informed through emergency ASBs, service bulletins, information notices, safety information notices. And you're very involved in that. We talked about customer focus group a little bit to reach our top company objectives. So once we have an in-service incident, if it's something that pops up a few times, then we have a decision to work that topic. And then we end up at the second gate where we have defined it and documented it. We know what to do to help prevent recurrences, as we had already discussed in the last slide. We come up with a solution, as well. The customers are involved in the customer focus groups, and we define the top objectives for a year. And for each type, we go for 3 to 5 for each program. So light helicopters would get 3 to 5, H-135, H-145, Super Puma, they would all get their 3 to 5 that their teams get to work on. And we follow through those gates, and we end up finally at a solution. And maybe you get a service bulletin to upgrade your aircraft to mitigate the issue, or it might just become something that's done through systematic change by AMM documentation or IPC. But you'll be kept informed throughout the process. So each year, like I said, we have a list of different top company objectives, which are based on the irritants or the in-service incidents that we receive throughout the year. And they are determined by, the top 3 to 5 are determined by input from the customer focus groups that we hold. These charts just show a little bit of what we're going to touch on today. As you can see, maybe we have a little more because we're looking forward a bit, but anyway, we tried to get a good cross-reference that would interest Canadian operators. So we're going to start, we're going to be running through this by ATA code, all right, and not necessarily by types. So it's by ATA, and you'll see the different types and models mixed in as we progress through numerically. So we're going to start with the 135 bleed air mixing valve. There's been some issues over the last few years with some, well, just issues of poor operation. And then, of course, because of limited repair possibilities, we had a long turn time on repairs. So why are you removing these? You're getting actuator failures where they don't function. You might not have regulation where you can't set your temperature in the cockpit, things like that. We see that we have a low mean time between unscheduled removals, 3,600 hours on average, which we find to be too low. And I'm sure as an operator you do as well. So the action plan for that was we worked with the supplier to do some improvements to make them more reliable. I'm going to touch on those in a moment. That process is complete as of today, as of this year. And another step or another aspect to that is in the minimum or in the master minimum equipment list, we've changed the rectification interval from a C to a D level, which means you have about 120 days now. If you have a failure or where it doesn't regulate correctly, you do have 120 days to rectify the situation if you're running on an MMEL. Step 2 is we're currently developing with the vendor a new direct replacement bleed air mixing valve. And part of the situation is the controller itself. So it's going to be a combined project. So we're going to see, hopefully, or not hopefully, but our objective is 2022 that these new parts will be available. What has been done by the vendor already, they've tightened up part tolerances where we found wear or misalignments or problems with micro switch alignment, things like that. They've improved the tooling for putting these together so that they're more reliable in that way. Just some different design features. And as well, they've trained their crews, their assembly technicians, on all these new improvements and how to assemble them and use the new tooling. Right now, we have a repair time of 4 weeks for customer-owned units. So this is down from significantly longer periods of time. So those are the improvements we see, and watch for more in 2022. Jumping over to the H-145. Some of you will have seen some of this already. The overhead panel mount, damper mounts have been cracking or breaking since really the C2 model. We have a new mounting installation being designed with new dampers. And we're gonna, once the retrofit is available, you'll be able to order an SB for that. So we had some improvements in initial SBs for the C2, but further work is being done on that, and we're hoping for fourth quarter of this year there'll be a new service bulletin, and you'll be able to order up the parts to upgrade your mounting. Moving on to fire detection on the H135. So we've had a few inadvertent fire extinguisher lights, well, or erroneous. What we're finding is they're related to the sealing becoming brittle on the backside of the fire detector, and this is on the Pratt & Whitney model versions. So once the humidity is allowed to get inside of there, basically we get a issue with some corrosion or some grounding, some shorting, and what we have is an erroneous light, which causes the pilot, of course, to try to put out a fire that's not there. So Pratt & Whitney is working on that. They've working on an improved sealing of that fire detector. And so that's coming out to you shortly. Remaining on the D2 and D3 models of the H145, some of you have noticed we have some issues with the current design of the air no fuel valves. You might experience slow filling, incomplete filling, that kind of thing. But the design, the old design or the previous design is such that it can allow the internal ball in that valve to hang up, and then that restricts any venting. So there's a new design which is impending, like right now. We should see this released and available by service bulletin here by the end of November. So watch for that, and that'll be a good improvement for you guys. And jumping into the lights, this is an issue that's been reported worldwide. Some people may agree with this one, but it was a 2021 top company objective for to solve this. The old hydraulic accumulator for the tail rotor, it's a little tricky to get to. You've got a small hatch to get through, or you go through the tail boom, and if you're getting like me, you're not that flexible and you don't want to go in there anymore. And even replacing or even testing, as you have to on repetitive cases, it was creating some problems. Guys were having a hard time getting the pressures right or checking the pressures, and in some cases even damaging the accumulator itself. So the project was to design a new on-condition accumulator, which is going to be interchangeable with the previous one. We are looking, or we've had an SB for retrofit with 2 customers right now, just starting now, which will go into service in the fourth quarter of this year. And they were already going into production aircraft as of October of this year. So we should start seeing these showing up. And depending on the ease of application for the service bulletin, then once that's completed, it will be available for retrofit on your new aircraft or your in-service aircraft already. I would think 2022 for general release. On the H135, or sorry, BK, the D3, there's a new, those of you that are operating them, you'll know about the auxiliary hydraulic pump. which is used for your pre-flight checks and things like that. The pump sometimes, or you may notice that you're not always getting the full 80 bars of pressure. And why is that? Well, in analysis, we see that the auxiliary pump, which is on system number 1, it's, the main pump, well, for now, sorry. So the auxiliary pump is in system 1, and it's taking fluid from the system 1. And as it's pumping, you'll see that maybe you don't get the 80 bars, but the main pump has an internal leakage rate that's predetermined. It's used for cooling and things like that. But that can vary with the position of the rotor of that pump. So if it's not exactly right, you'll find that you can't get the 80 bars. And also with your tail rotor servo control, the valve can also, depending on position in there, you can have a high leakage of internal or high internal leakage past that valve, resulting in low pressure. You're not going to be able to do your checks as well. So first thing to do is get the pump up and running, move your tail rotors or your tail rotor pedals from stop to stop, or you can have somebody up top just turn the main rotor blades a little bit. If that's the case, and you should start seeing the full 80 bars of pressure. So this is not a groundable item. This is just a design feature, let's call it. It's just the way it happens. And once you know about it, just move your pedals back and forth. You'll get your full pressure. Nice and easy. Something we've been tracking with for a couple of years, the T0 issue, creating an amber gov light in service. What the problem is here, we know it. It's well known now. Differential of your cooling probes on the belly panel. There's a few different reasons: shade, rain, water bucketing, whatever. But by having this light coming on at different times of flight, what our concern is, and what everybody's concern is that we end up with a potential complacency on the aircrew's part, because they're getting these unnecessary alerts. So this becomes a top safety issue. So we're working with Safran to right now, because it's a joint venture, it's a joint system. We're working on increasing the tolerance that the system can handle between these two probes. So watch for an upcoming update on that. Jumping into Super Pumas, some of you may have realized this issue, but on the 225, we do have an issue at times of the crank switch not functioning. Pretty much what's happening there is the switch is getting a large supply, because it's basically straight to source. What we're doing, the proposed solution, of course, is to supply a relay, to put in relays, so that you're now supplying the coil of the starter through there and not directly through the switch. So what you're going to see by retrofit is some relays added into the 185 VU, which is your cranks plate there. And it'll be retrofittable by you, the operator, so that you can minimize your costs there. And it would also be available, you could buy as new, but obviously we would like to go with retrofit. For a few years, we've been dealing with the frame attachment web at the 22-degree frame on the H130, 130B4, T2 versions. So we've in the past, we've had to provide RDAS solutions, repair design. And recently, these repairs were made available in the AMM as part of a big project to move RDASs into there. What do we see? Why is this happening? Because it's been throughout the history of the aircraft. During assembly, we have a gap between that web and the 22-degree frame. So what have we done as a protective measure? If you go in, you're checking it every 150 flight hours or 12 months. So that's at your S inspection. Moving forward, we have a design correction coming out that will be applied on, or are being applied now since October on the new T2s. And then we're going to, one final thing, because we have the correction, we have the fix in the AMM 8-19, the inspection AMM needs to be updated so that you have a hyperlink to go directly to the repair. So that'll help you as a maintainer and repairer. Final compliance on that, we're aiming for Q4 2021, and that was one of our top company objectives for 2021. And that is actually, I think, complete now. So tail boom fenestron junction. We've been presenting on this for a few years. We're down to one slide. We're very happy that things are moving along. Just a reminder of where we were. We had issues with stabilizer fittings cracking. That's been fixed through improved fittings. Stabilizer opening in the tail boom, so just behind and to the bottom corner. We were having some cracking, so the larger doubler was installed. And on the fenestron junction, the fenestron side, we were having cracking, and everybody, or a lot of you, will be familiar with the oversized rivet fix for that, which was mod 4609. Now we're in the last stage of cleaning up the fatigue cracking in that junction. And we have a service bulletin 53036, which is adding 4 external carbon patches to the tail boom. This is a D-level activity, so only AH approved technicians. And once this is embodied, it's the cancellation for all AD inspections then in that area of the tail boom. So in the field, if you're pre-mod 4609 or the large rivets and you have no RDAS repairs to the skin, we can do that in field, in situ. We have 2 D-level technicians trained and traveling, or you can bring the aircraft to us and we can do it. If you're post-mod or have an RDAS on the skin, repair on the skin, then the tail boom needs to be removed and sent to 2 jigs that are currently in operation with guys changing that junction. We have a mandatory deadline for December 22nd, 2022, as required by the Airworthiness Directive. And in Canada, we have 23 tail booms as of today completed. We have 13 remaining in the Canadian fleet to clean up. And of those, we have 5 which are work in progress right now. So by early in the new year, we will have that number down well below 10. So we're well on track to meet the objective of December 2022. As some of you know, there's a new design of tail boom for the 130 with a new tail rotor drive shaft setup. It's a two shaft setup with a bearing in the middle. There's been one case of a degradation of that bearing damper or the bearing support. We don't know what caused it, but we're investigating it right now. And hopefully we'll have some answers in the short term. But immediately for protective action, because of multiple aircraft out there, it was mandatory to release to you or release a mandatory EASB with an airworthiness directive to start doing repetitive visual inspections on this area to complete or to keep flight safety at its level. When you receive the bulletin, which you already have, you have to inspect the area within 7 days. And then after the last flight of each day, what are you looking for? You're looking for missing, loose, or sheared rivets of the bearing support. If you look in those photos, you can see some points that you're focusing in on. And you also don't want to see, obviously, any cracking in the frame or skin area. If you do, you need to, if you see any of that, you need to get a hold of us in tech support. Corrective action on that, of course, we don't have visibility on that because this is such a new topic. But in Canada, we're looking at 2 helicopters impacted by this right now. Super Puma 2020 top company objective. Frame 9000 cracking. This is, of course, your tail boom junction for the Mark 1 versions, so L1, that kind of thing. There's been a few occurrences. ISIRs have been raised. What we see is this is mostly on aircraft that have been carrying heavy loads, not necessarily just passenger transport. So when these are loaded, this is when you'll find this issue could come up. If you find this on your aircraft, contact us at tech support. We will raise a web technical request for each case that you find, and we will request a repair, which will be an RDAS, which can be applied in the field. In conjunction with that, right now, we're working on a local reinforcement of that area. So this will be something that can be done at your facility by applying a service bulletin for that reinforcement. Objective for final solution is the 4th quarter of 2022. On the C2 and D2 BKs, avionics deck, you'll have seen there's cracks in different areas. There's multiple ones. So we're just stating that generally, have a look at these service bulletins. Essentially, you're looking at de-riveting the areas where they're cracked, and then you're adding in some reinforcement angles. So if you start seeing that, refer to these service bulletins for the C2 and D2. An ongoing topic for the Ecure operators out there, there's an update on your mass sleeve inspections. Okay, we had an ASB or 2 on that. It was a 2020 top company objective to clean this area up. That is now complete. The ASBs for inspection of the area have been incorporated into the MSM since the 2nd quarter of 2021. So now you follow the MSM requirements. It's a 600-hour, 24-month, basically your T inspection. You're going to check your sealing bead and sleeve for rotation. The increased limits of 90 degrees. That sleeve can turn up to 90 degrees. If it goes beyond 90 degrees, then you're going to have to contact us and bring the shaft in for repair, and we can replace that sleeve for you. The secondary part of that, the ongoing, is for seal leakages, the upper mass seal. We continue to have several cases, and you're going to know this when you remove your upper main or your upper drain plug. You're going to get some oil out of there, so it's going to be time to schedule a mass seal replacement. Why is it doing that? What we're finding is the primer that's applied at the top could be too thick. It might be applied rough, or it might just be flaking, which is damaging the seal. This is a big job, as you know, up to 45 man hours, and your aircraft is down for a while. Protective, when you run into this, thank you. When you run into this, please come to us in technical support, and we will raise a web tech event, and we'll be telling you that you can remove all the primer off that area. And there's an ongoing corrective action that AH is working on, which is a solution to eliminate the primer, and there will be a new corrosion protective action in that area. So watch for that to come and to go into production aircraft as well. Main rotor drive on the Ecure, of course, or basically the 350 and 130 has been affected mainly by the main gearbox input seal leakages. Just a reminder of the two seal leaks is statically past the O-ring and past the lip seal in operation. So the O-ring solution is complete, mod 7240, and now is simply to redesign the drilled spacer and the friction ring. Essentially, we were relocating the O-ring position. So that's done. It can be done by you, the operator, if you still have pre-mod inputs. So ongoing, what have we been doing? Some improvements. We have a new friction ring, which was introduced in the last few years. We also introduced installation procedures, limited grease on the lip seals as part of that, and a redesign tool. You got that from an information notice 3122. And pay attention at this point, on the bottom left is the improved seal, and right next to it you see it with the seal installed. Just remember that for one moment. While that seal tool worked fairly well, the extended portion of it was actually designed for the seal to sit on for installation, but it's taking the place of the friction ring itself for installation purposes. Here in North America, it was designed to remove that area so that we could use the friction ring as part of the tool for installation. The benefit to this is, as you can see in the middle photo, we can install the seal on the friction ring, and we can see both the main seal and the surface of that, and for the dust seal. So we know that both parts are properly installed. There's no twisting or anything like that. Once you're clear of that, you slip it into the improved or the modified seal tool and use that to push the seal in. We've had a lot of good results with that. Operators are reporting back that even just that action alone is getting them hundreds of hours without any leakage. The final corrective action or the improvement that Airbus is working on is a vented seal installation, which that seal is made of a new material, and you'll find when you receive them, there could be a small hole or holes in the inner lip, which is designed for heat dissipation and operation. So that's going to hopefully, or that's been cutting down on the coking situation or the burnt situation we see on some of these seals coming out. In the one photo, you can see the blue circled area. That's to indicate where you'll find the small hole. This has been now almost a year in testing with customers worldwide. There's a service bulletin for the 350, B3, and for the 130s. We have a few in Canada running right now. We've had great results. So we know we're going to go into production in the first quarter of 2022 on those seals, and then they're going to be followed up for spares installation after that. And one further improvement under mod 7244 is going to be the scallop cutout in the housing for the input. And you can see that in the other photo, the circled red area. Basically, that's allowing oil to drain back into the gearbox, especially in shutdown prior to start again. We don't get any pressurizing. So that's where we are with those. Into the main rotor drive on the Super Puma. As the L2 and 225 operators know, the full flow magnetic plug has been in service and mandatory for a while now. We've gone there with the Mark 1 series now as well. So by April of this past year, or of 2021, we should have had full compliance with operators to run the FFMP, or the full flow magnetic plug. One drawback, but not a really bad drawback, is the particles. Now with a full flow magnetic plug, you're gathering more particles. It's much more efficient. So as you know from the Mark II and 225, the close monitoring became a really heavy maintenance burden. You had extra characterization of all these particles, and you had to send all these particles to a lab for analysis. What they find there is most are not representative of mechanical degradation, and the flow chart that you have to follow is somewhat confusing. So what are we doing about that? We're going to do just like on the L2 or the Mark II and 225. We're aligning the Mark I versions to that, where you're going to see the work cards for the main gearbox particle detection are going to be specific now. There will be a card specific to the main gearbox, and it's going to be much more clarified. So you will be able to, through a very clear identification of particles done through the standard practices, which is already updated and available to you, you'll be able to narrow down easier what is actually particles that could ground you or to go for further analysis. So we're looking at the fourth quarter of this year or first quarter of next year to have all of that implemented. So you'll see that coming. As a product improvement that is initiated by that, Gastops has a tool called the chip check. And we're in right now, it's under assessment at different customer centers throughout the AH network. And what our objective here is that this tool can, if all tests go properly and we're good with it, it's going to be a quick release, or you'll have the possibility of quickly releasing your aircraft after you've gotten particles on your FFmpeg. This will analyze those particles, and so it'll really speed things up. It's basically you're going to analyze the chips on a slide, and as long as they're not of 16 NCD 13 material, you'll be able to release your aircraft. And so on we go. And you can see at the bottom, the current process is time consuming. You got to go to a lab, come back, and then get your airborne or your aircraft airborne again. If this gets used, we'll have same day service essentially. You'll be in the air. Another improvement related to the main gearbox. A lot of times when your Super Puma is out of service, it's either in storage or in maintenance. Maybe you have it sitting up on jacks, engines are removed, that kind of thing, just a heavy maintenance situation. Your main gearboxes or your main gearbox needs to be run on a regular basis unless you put it into long-term storage. Long-term storage in itself is a lot of extra man hours and complexity to just remove it, store it, and then keep up the storage. So what we're proposing will be a lubrication bench, which you'll use periodically to lubricate your main gearbox. You'll run it through the aircraft lubrication system. You can use preservative oil, or you can use just the normal operating oil, and you won't have to remove your main gearbox. A little update on our tail rotor blades, Fenestron tail rotor blades. As you know, we're tracking on 130 and 135s. We had one case of a tail rotor blade rupture in service with three cracked, all on the same tail rotor hub. We've seen that it's a progressive fatigue failure out of the drain hole, but that we think is leading from non-conformance of the position of the hole. So you were notified through a safety information notice and reminded again of proper maintenance procedures and inspection procedures. So for checking, there was an NDT inspection for the 130. If your blades were over 1,500 flight hours, you had to do it in a very quick order. And if you found a cracked blade, obviously out of service immediately. But if you didn't and you did the rest of your checks, there was a situation where you might have one parameter out of criteria, which made you a category B blade, which could be operated, but then would need inspection every 20 flight hours by fluorescent penetrant, which of course in Canada is extremely difficult as that's specialized maintenance. But thankfully, we haven't had too much of that going on as of today, or as of this month. We've had 2,679 blades checked and reported on so far. The target is 5,000 for reporting. Of those blades, 95% have been category A. So back into service and operating on normal inspection frequency. Category B was 2% of the blades, and C, meaning it failed one of the criteria, has only been 3%. So we've had very good results there. And you are, of course, asked to report through WebTech your results, because that is how we get our return of experience, and that is how we can ensure that YASA is satisfied with all the results, and we won't see further action on blades. Just a little note, if you're using the app and you're failing or not doing very well with the app, just take your pictures and use the PowerPoint tool to evaluate everything. And that's the same if you fail in the app, check it again on the PowerPoint. 135, because of similar blade design, was also implicated in all of this. There's a one-time inspection of the drain hole. Again, there's an app for this. You have 3 dimensions to check again, remaining thickness, rib thickness, and hole access to shoulder. If all those are within dimensional limits, your category A and your blade remains in service. If you fail one dimension, then your category B and you remove that from service. You are going to report your results through WebTech again. There's a section in the bulletin to do that. Same thing about the app versus PowerPoint, as I just mentioned. And while we don't have specific results up here, we know that category B blades have been very rare. So good results there. Moving on to the BK, all the way up to, for tail rotor blades, tail rotor assemblies, right from initial model right up to the C2. We've had cases of excessive wear and damage on components. So we're talking pitch link rod ends, tail rotor hub bearings, things like that, due to, maybe not looking at it enough or taking them out of service soon enough, tail rotor balance not being kept up. This can lead to some really serious consequences, of course, which of course we have seen actual cases where tail gearboxes have cracked in service. So again, back in this is an issue that was noticed many, many years ago. But then in 2011, it was starting to show up again. Safety information notice was issued in 2011, and then it was updated and reissued again this past year in 2021, because we continue to see these cases. So get up there, have a look, and keep those tail rotors balanced. Jumping over to the D2 and D3 on the 145s. Some of you might have seen, as you get new blades or when you're getting into inspection, you might see some fiber splinters just in the strap area, just outboard from the attachment bolt. These are from manufacturing, and they're not at all affecting the safety of the operation. When they're produced, those splinters are removed, but as you operate it, the few that weren't detected during the manufacturing can show So basically you're going to sand them off carefully, and then you're going to seal the edges up to keep them from reoccurring with some high sol. Okay, servos. Good news coming out here. The Goodrich dual servos on the H125 or 130 series aircraft, we've had traditionally or historically leaks from under the right or from the limit switch cover. So that's your forward right hand servo. The leaks would happen in cold weather. The vendor, Goodrich, has been working on an improvement for the seal, which is now basically been tested and found to work very well. So we're looking forward to new seals being installed systematically in 2022. Novintec servos for the same aircraft. So some aircraft were released with the Novintec servos, and we were having some recurring issues of failing the pre-flight test or on your servos on the ground prior to flight, or you get a caution light in flight. That is related back to the micro switches, rigging of those, which we're not as technicians allowed to touch. What happened, we went back to Novintec. They worked on the micro switch rigging and the tolerances available in there. And now when you get a Novintec servo that is Amendment G on the data plate, those are the ones that are post, let's say, improvement. And they should not give you that same problem. And in January of 2022, Novintec will be receiving Transport Canada approval for repair and overhaul. So that'll ensure that we have a lot quicker turnaround time on servos when they're needed. The 135, an old topic, I'll just quickly revisit the MRA tie bars. We had a case of one breaking. That's due to corrosion. So the longer they're installed, and they were corroding. In 2019, there was a campaign out to inspect the MRA tie bars in a group A, as we called it, meaning aircraft or MRAs older than 6 years old. So there was a campaign to train people to do this inspection. And if needed, you could replace the tie bar. A year later, we revised that bulletin to increase to a group B, that we called it, which was less than 6 years, but greater than 4 years, or let's say, call it around 5 years. It became an ASB, not an EASB anymore, because the results coming back from the initial inspections was good. So YASA was happy. We were able to downgrade to an ASB, but now you have a repetitive tie bar inspection on all MRAs that will occur every 5 years. Why you might scrap one of these out, obviously, is for corrosion or thread damage from the lock for the end nut. Corrective actions coming up will be a modified lock, which won't damage threads, and better sealing of the actuator to prevent just basically moisture and just debris from collecting and creating corrosion. We've had some issues on the BK C2 and D2s with the SEMA actuators, their reliability. There was an old generator or old generation SEMAs installed. Mostly we saw wear of piston guides and internal corrosion, causing premature or just early removal. A improved actuator was made and was put into basically into service with the start of the D2 when they went into production. We had good improvements, some improvements over the original generation, but still needed work. So there is now going to be a new generation developed. It's in final testing right now with good results showing. So we should see that here this quarter, fourth quarter of 2021. So watch for a retrofit service bulletin for that. 135 T2 issue, bit of an irritant, obviously. We have a minimum fuel temperature for engine start of -19, which is quite limiting in Canada. But Safran Engines has come up with a modification, TU-152, which allows for engine start up to -35 degrees below 3,000 feet pressure altitude. That is a software change in the FADEC. So that is available. And that was the first step. Step 2 is cancellation at all altitudes. And that'll be TU-154, which we should see here at the end of 2021 or the beginning of 2022. For now, there is a table for engine restart based on time sitting in relation to the OAT. So refer to IN 2994 for that. Jumping into start switches on the 135 and 145 across the board, lots of failures on the 20 VE panel switches, the on-off switches. They just were not great quality, and they were failing quickly. So there has been a new switch redesigned, a new design of switch, and those listed SBs are for retrofitting your current 20 VE panels in the 135 and 145. So you'll get better results on those switches. One point, some of you may have changed them on the 135 and had them fail again. There was a batch of poor switches that came out. Those have been identified and mostly gone, and the new ones coming now from the vendor are cleaned up and good to go. Overspeed protection of the Ariel 2 Delta engines. So we're talking on the T2 and H125. The problem or the issue that we would see in the case of a possible overspeed condition, you do have blade shedding due to an overspeed. But then without the blades there, then overspeed can maintain and then further problems occur. So Safran developed a shutoff feature, which is TU-210. And on our side, we came up with mod 4831, which is wiring changes to implement TU-210 into the airframe. This is specific training and tooling, the first service bulletins that came out. So that had to be done by our technician. The next step was another mod to allow you as an operator to carry out the wiring changes. So you would receive a different harness, that kind of thing. So it's much quicker for implementation. You don't need to have us on site. Right now, these kits are free of charge. So once you have TU-210 on your aircraft, then you can apply the service bulletins for the 125, 760028, or on the T2, 76008. Once you've got TU-210 or you're planning to get it in there, get a hold of your CSR and order up that kit. It is free of charge, and we want to see everybody with those installed. Start switches on those same aircraft. Your 26K on-off start switch has been problematic. So again, this one's being redesigned, and it's a new switch manufacturer, a new, more reliable switch. The objective here is to reach a mean time between unscheduled removal of at least 5,000 flight hours. So watch for that coming shortly. So product improvements. We're going to touch on some maintenance improvement program points. D2 to D3 quick overview of the retrofit. An update on the mass spacer tube and the 145s, BA to B2 conversion, quick touch on crash resistant fuel system, performance increase, and new tail boom on the 130. So how do we let you know about improvements as the operator? So information letters can be found right on your Airbus World dashboard. You'll see them go across the top. You can click on it there, or they're also found on Tippy, so you can get your information letters there. Or as well, information notices, service letters, safety information notices, all that stuff come up in Tippy as well. So that's how you find out about improvements other than presentations like this. A 2020 top customer objective was improvement of the SIM in the Acura version aircraft, so 350 and 130. As you know, many of our maintenance tasks are dependent on the mod status of the aircraft, and sometimes you'd read the statement of what that modification was, and you were maybe even more confused than when you started. So France began a project for last year where they would improve that SIM, and part of it was making more clear the description, but also having linked documents that show and explain that service or that modification a little more clearly. So that was released at the end of 2020, and it's a project, or not even a project anymore. It's just an ongoing thing in technical publications for the light helicopters at this time. So that is an objective achieved. A new one for 2021, top company objective is extension of the T inspection. We're looking to increase the T inspection on the B3 to begin with to 750 flight hours, so multiples of 150 flight hours. And with margin, of course, that would line you up directly with your engine at 800 flight hours in 2 years. So how does this help you? If you're a high flyer, you get to do 1 T inspection a year. And in that case, our goal is to reduce your maintenance man hours by 10% on the B3 right now. So what is the scope? Again, I said the B3, mainly the tasks that will get extended are at post-mod statuses. So if you are pre-mod on something, you may not find that you get to go to the 750, but some pre-mod items may be classified to 750, but that's undergoing analysis right now. This is a longer project, obviously. The goal was to get it launched this year and get the objectives set. So our objective is to have this available to customers, operators by 2023. What's happening is they're taking a look at all maintenance tasks, which includes optional installations. That comes to a total of 137 tasks. That's in your T inspection, multiples of 600 hours, so 1200 hour, things like that, as well as OTLs and TBOs that align with that 600 hour or multiples thereof. So at this point, current man hours to complete a T inspection are around 78 man hours. With extensions to that to 750, your workload at 600 flight hours, because not everything will be able to be extended, they'll become one-off standalones. The best case final solution looks like will leave us with 12 tasks remaining, which amounts to about 3 maintenance man hours, or only 4% of that 78 hours. The worst case scenario is that we can't extend too many of them, which of course we don't think that will happen, but you could end up with 77 tasks remaining with still 47 maintenance man hours. I suspect will be closer to the best final extension than the alternate. Another improvement is in the EC-135 maintenance check flights. The irritant there was operators having to do lots of maintenance flights after just a lot of different maintenance tasks, which didn't seem to be necessary. So that's been gone through, and there's a reduction of the requirements for mandatory check flights. Have a look. It's there's other means of compliance, different ground functional checks, things like that. So on your T2 and P2, we've already got that implemented. The next aircraft will be the T3 and P3, which should be scheduled for release this year. And then we're into the Helionics version for 2022, and then going back to the T1 and P1 as well in 2022. So we'll have all versions of the 135 harmonized, and we won't have a lot of maintenance check flights required, which will really reduce your workload. On the sliding doors for the 135, there wasn't really criteria for where on the sliding door rails. So what did we do? There's going to be, or there is, detailed inspection criteria now in the AMM. So it's very similar to the H130 if you work on both models. That's done, and that's in Orion already. So if you haven't been in there to see yet, that is there. Another improvement, which was a bit of an irritant, there was a limited number of structural repairs in the 135 structural repair manual. We had lots of RDASs that you could get, but you would have to request them and go through that whole process. So like on the light helicopters, there was an action plan made to update the SRM to put RDASs in there, and that is now completed. So you'll find a lot of repair information. And for the rest of it, as time goes on, as we see more things in service, as we gain more hours on the type, you'll find that any RDASs that are developed moving forward will get put into the SRM as needed. 135 again, fenestron blade wear limits. A lot of operators finding erosion and impacts were leading to really what we felt were premature removal of those blades. Testing has proven that out. So there's an extension to the damage and repair limits of those blades. How is that getting implemented? Because this is new. The first step, and that means right now, is we can give you extended limitations by issuing an RDAS against your aircraft. So if you need it, you contact tech support and we will get an RDAS written for your aircraft. And then in 2022, the AMM will be updated for these new limitations. So D2 to D3 H145. So this is the latest version. Here you can see which topics or which items are changed as we go from a D2 to D3 in production or by service bulletin. You're looking at a new main rotor system, new rotor mast, obviously eliminating the main rotor head. There's changes to swash plates, scissors, all the control rods, that kind of thing. There's a new horizontal stabilizer. You add in the electrical hydraulic pump, and rear blade, or now you'll have a blade folding option, all blades going aft. Wireless aerial connection server will not be available from D2 to D3 service bulletin installation, but you also get a new forward cross tube. You get to remove the 3 Hertz dampers off your landing gear, and you get to remove the LAVCS because with the 5-bladed rotor, we don't have any issues with vibration. So what are you getting? You're getting some rotor blades if you do it by service bulletin. You're going to get a mass wash blade scissors, control rods, another oil cooler and rotor brake. In addition, you get a new hydraulic pump, new forward cross tube, H-stab, and then some software for your helionics. So an upgrade there. It's a 5-bladed main rotor now, no main rotor head. So we use what's called flex control units, which the 135 guys will know. And this is technology taken from the 135 blades. So all the flight control actions are taken in the flex control unit. That goes directly to your mast flange, and then you have a main bolt and a secondary blade bolt to attach the blade to each flex control unit. Because of this design, like I said, we get to remove the active vibration control, the LAVCS, and the dampers off the landing gear. This main rotor system goes to on-condition maintenance. So we don't have a head that needs oiling, things like that. Okay, and no seal changes, whatnot. What are some benefits here? So max takeoff weight in category A increases to 3,800 kilograms, an extra 100 kilograms. How did we get there? We lose about 50 kilograms of the empty weight by removing the landing gear dampers and the LAVCS. And then we get a performance increase as well from having a 5-bladed system. So we end up with an additional 100 kilograms of weight capacity. And the nice thing about it is too, we lose about 20 centimeters off the footprint of the aircraft when blades are turning. Main rotor mass spacer tube. For those of you that have been running C2s and D2s a little longer, you know that we've been working on the mass spacer tubes because of wear on the upper keys. There was a new spacer tube with 6 keys introduced a little while ago, but this did not eliminate the wear. It improved it, but did not eliminate it. So more design investigation, of course, and what the reason we're seeing the wear is because of, as you can see in the one diagram there, based on mast moment and turning of the rotor, you're getting an oscillating action on that spacer tube. So the action plan to reduce that or eliminate it, there was new designs being evaluated. There's a new design that has been agreed upon, and they're going to start evaluating in the second quarter of 2022. If we get good results, the plan is to release that in third or fourth quarter of 2024. So there'll be some extensive testing going on. For some operators that operate BAs, they wanted to convert to B2 in the past. That's been an activity that has to be done by Airbus helicopters. So not done by the operator, has to come back to us. There was a request out there, can we start doing it ourselves as an operator? So AH reviewed it all and decided, yes, there is a good case for that. So now you can request for your BA a serialized service bulletin, and you'll get a bulletin written specifically for your BA and parts that go with that. And you can do that in-house now. Crash resistant fuel system. I'm just going to quickly go over this. As you know, there's a retrofit by Airbus helicopters for the B3 range and the B4, standard aero for all versions of 350 and the B4. Quick update on our airframe fuel filter. The 130 T2 is now qualified CRFS, as is the H125. Very quickly, how did we get to this? I'm not going to go step by step. The big thing we want to point out is full CRFS without a hook is realized when you install the reinforced fuel plate and the reinforced cradles, or just the reinforced plate, depending on your previous mod status. Once you have that, you have full definition of CRFS. If you put your cargo swing on, of course you didn't, but now with the onboard swing provided by Airbus helicopters directly, you do have full CRFS again now. And onboard also has their version through their STC, and you can contact them there. This is the same with the Ariel 2B and 2B1 equipped aircraft. Going into the 130 area, again, get that reinforced plate in there, and we're working on full compliance for crashworthy on there as well. Well, through that. 125 performance increase. So that is now available. So this is a software update where you're going to basically increase your max takeoff weights. Your external loads are going to go up 120 to 140 kilograms, depending on your altitudes. So that's now available. As well, BLR has taken that into account, and you're going to see if you have that installed on your aircraft, you're going to get increased payloads as well once you update your VEMD software. Quick thing on the tail boom, right? On the 130, there's some changes: new engine cowling and rear firewall, or new rear cowling, new tail rotor drive shaft, new tail boom structure. What does that look like? You can see the previous versions and now current. Improved drive shaft covers. There's a new fenestron to link construction. It's now resin and composite. And yeah. Here's a little bit clearer view. It's a monolithic design. Everything's coming together and joined together. And you now have a molded H-stab opening, much like your H120, 135, that kind of thing. So we've taken care of any issues there. And there's your new firewall and transition cowling. There's a new labyrinth type seal for the firewall at the back. Drive shaft, of course, as you've seen previously, is a much improved version. 40,000 flight hours now. You're getting rid of the multiple bearings. We have a single bearing, but we have hypercritical shafts. So again, that's going to take extra diligence on your operation and maintenance around them. But they're very durable, and you've got a 5,000 flight hour life now on the bearing, and of course 40,000 flight hours on the shafting. So these are a great improvement. So thank you. I think we've been handling questions as we've been going along, but if there's more, please pass them our way.